Grade 11s, welcome back to part 2 of the second lesson of winter school. But let's just recap quickly. We've looked at what the mole is. The mole is the SI unit, but it represents a number of particles. And I showed you that it could be just like a counting unit, like a dozen, using the coin activity, and we've used that equation in calculations. It's now time for the activity. Again, 1 teaspoonful. And this time I took various compounds. I want you to record the mass of 1 teaspoonful of each compound. So let's look at the first set of compounds I pulled out of my back room in my school lab. Okay, here we have calcium chloride, 0.14 grams, 1 teaspoonful. Barium chloride, 0.30 grams for 1 teaspoonful. Then we have lead bromide, 0.27 grams for 1 teaspoonful. Manganese oxide, 0.26 grams for 1 teaspoonful. And sodium carbonate, 0.55 grams for a teaspoonful. And magnesium sulfate, 0.21 grams for a teaspoonful. So back into the chemistry storeroom with my teaspoonful and my mass. There is sodium sulfate, 0.32 grams for a teaspoonful. There is sodium nitrate, 0.22 grams for the teaspoonful. Potassium iodide, 0.34 grams for the teaspoonful. Lead iodide, 0.27 grams for a teaspoonful. And there is potassium dichromate, 0.26 grams. And finally, calcium carbide, 0.31 grams. And with my teaspoon headed back into my storeroom, there is mercury oxide, 0.47 grams for the teaspoonful. There is copper chloride, 0.20 grams for the teaspoonful. Iron sulfate, 0.17 gram for the teaspoonful, and lead nitrate, 0.38 grams per teaspoonful, and finally copper 2 oxide, 0.32 grams. So grade 11s, I would like you to use this formula to calculate the amount in moles of each of the compounds. Now, we have said that in 1 mole you get 6.022 times 10 to the 23 number of particles. But is this true? I want you to think of the following. If I had 0.1 mole of substances, how many particles are in there? So there is 0.1 mole of carbon. It has a mass of 1.2 grams. Of sulfur, 3.2 grams. Of lead, 2.07 grams. That's 0.1 mole. Then for magnesium, 0.1 mole has a mass of 2.4 grams. Copper has a mass of 6.4 grams. Potassium dichromate has a mass of 29.4 grams. That's for 0.1 mole. For lead iodide, the mass is 46.1. And for potassium iodide, it's 16.6 grams. And for lead bromide, it's 36.7 grams. That is 0.1 mole of each of those substances. I want you to verify using that formula how many particles are in each bottle. Now, what we haven't looked at is molar volume of gases. Any gas at STP has the same volume. That's how Avogadro actually came up with Avogadro's number. And that volume at STP is 22,4 decimeters cubed. So 1 mole of nitrogen actually has a mass of 28 grams. 1 mole of oxygen has a mass of 32 grams. 1 mole of hydrogen has a mass of 2 grams. 1 mole of helium has a mass of 4 grams. And the number of particles of any gas, whether it's ammonia or water vapor or oxygen or helium, will be the same in each of those balloons at STP. So that is the formula that we can use to calculate the amount of a gas or its volume, knowing that its molar volume is 22,4 decimeters cubed.